When it comes to agricultural residues, those are not used to its full potential. That was the starting idea of the next team, BioCharge from École Polytechnique. The stage is yours.
Before starting, I want you to meet Pedro, a rice producer in Mexico. Today, Pedro faces two main challenges. First of all, he has a lot of unused rice waste, which, since it's the cheapest way to get rid of it, he burns it. The second main challenge is that last year, he lost 7% of his crop yield due to droughts, but also because of decreased soil fertility. This is where BioCharge steps in. We help farmers use their unused agricultural waste in order to produce biochar. Now, you may wonder, what is biochar? Biochar is also known recently as the new black gold. In particular, it's a specific type of charcoal which has interesting physical and chemical properties that give it a lot of very interesting applications. For example, it can be used in soil remediation as we want to use it. In this case, it can help improve the crop yield in the tropical areas, as well as to help have more water retention in soil. At the same time, because of the production process of biochar, the production of biochar helps sequester carbon. And actually, since you're actually taking carbon from organic matter, it's one of the highest quality carbon credits out there in the market, which means it's highly coveted, expensive, and right now, there's not that much produced. In fact, the IPCC has estimated the global predictions of the potential of biochar to be 2.6 billion tons of capture per year, which is around more than the aviation industry worldwide. To go a bit more in depth into how biochar is produced, it's going through a process called pyrolysis. This process has been going on already since a couple of decades, and you take organic biomass, burn it with low oxygen, taking the O2 out of CO2, which gives you this rich carbon content, which is called biochar. At the same time, we produce gas, oil, and other things that we can valorize to produce excess power that can be sold, and then just give it to communities around. Now, if it's so simple, you may ask, it's input, output, boom, magic product, how come it's not there yet? Well, in reality, it's much more complicated than this. The system depends on a lot of factors that give a lot of different variability according to the conditions. And in fact, the efficiency of your biochar will depend on many of these, which means that unless you find the right conditions to make it work, it's very hard to make it profitable. This is why we've come up with an innovative business model where we want to take optimization models and our background in mathematics and technology together with the EU carbon markets, which are stronger than ever, and they're going to keep on increasing, to make accessible biochar for Pedro and many other farmers in developing countries. Now, Philippe will explain the rest of the solution.
Yeah, so our project will be split in two phases. First, we'll build a pilot phase where it helps specifically Pedro installing a small plant right at his rice mill. We're going to use all of his rice husk, produce biochar, co-generate electricity and heat, sell all of that to Pedro's facility, his farms, and his farmer partners. This pilot phase is also important for us to get all the necessary certification for the EU carbon market and fine-tune our optimization models. So even though this plant is a small step for biochars, it's a big step forward for a sustainable future. Not only do we get the environmental benefits that biochar gives us, so a lot of CO2 captured, a lot of agricultural waste that is valorized, but by targeting developing countries, we also get a lot of social impact. So we take money from big European polluters and give it back to those who are most vulnerable to climate change, essentially using the European carbon markets to the extent that they were designed initially. And we can also power poorer and remote households with clean energy, heat, and better agricultural products. So yeah, good news from even this one small plant. But now you may be wondering, how does this all scale? Well, I invite you to look at this map over here. And as you can see, there's a lot of red on this map. What does this red mean? Every red area means that the UN considers this soil as very degraded soil, which means that every red spot could be a potential biochar plant. Well, of course, not all of them grow rice. Well, that's not a problem for biochar, luckily. Any dry residue works. Also, it's very clear that we cannot use the same deployment model and the same plant design everywhere on these red spots. Well, this is exactly where our digitalization techniques come in. By simulating a lot of possible plant designs, a lot of possible deployment models, we can see which one is most efficient for every specific location and bring accessible biochar to everyone around the world. Right, so this slide gives a quick overview of the global biochar market. You can see here we have the European producers who take the highest quality biochar, highest quality inputs, but that makes it unaffordable for farmers, unfortunately. They only sell to individuals. There are also projects that are more similar to ours, such as Net Zero and Husk Ventures. They take a very traditional approach to scaling, looking at every new plant manually, which we think might be slow, and we hope to bring a breath of fresh air in this very traditional industry and scale up faster. But additionally, after talking to all of these producers, we realized that there's a lot of space for newcomers in the market, and right now competition is not a big concern. All right, thank you for your attention, and join us to kickstart the next farming revolution.
Do we have other members from your team?
The rest of the teams, we're in final exams right now, so most of the other guys couldn't come right now.
All right. So you will be now examined by the jury.
Well, so you have a very nice idea that fits into the current world. May I ask, how far are you to the realization? What has already been done and which steps remain?
Right now, I want to show just, we did a lot of scoping around the current state of the biochar industry. So we contacted a lot of experts and manufacturers that have already experience in there. We also went with industry partners who, as we said, were very open to have newcomers in the field. So they gave us a lot of tips, ideas, and also like kind of gave an overview of how it works, what doesn't work. At the same time, we also contacted Pedro. Yeah, as Philip said, he's a real producer in Mexico. So we talked with him already. He told us his waste, and actually he would be interested to partner with us to have our plants in his site, should we proceed with our project. Now the next steps, of course, would be, first of all, to proceed with the funding, and at the same time to concretize all these partnerships that we have, to get some contracts, and then just proceed with the scoping of the actual site that we want to make it a reality.
Okay, thank you. I'm a bit unsure exactly what is your product. Is that sort of the device or the oven that sort of creates this product? Or let me ask in another way. For the pilot project, you had a budget for, I think, 300,000 euros. Could you say what are those money going to? I mean, what are you going to use that money for?
So this 300,000 euros would be used to just build the plant in Pedro's facility. So here we use existing plant designs that we tweak a little bit to just start a pilot, see if our calculations are correct, see if everything is correct. So this, would just be an existing biochar plant, as the one that we showed multiple slides before. Later, for the scale-up, our product would be more the models and the optimization tools that we will have to help other Pedros and many other farmers around the world build the most efficient biochar plant for their site.
Thank you. So you mentioned that biochar is a new black gold, so obviously a lot of other teams are attracted into this market as well. And you also mentioned that you want to offer it at a reduced price than your competitor. Can you please very clearly explain who your competitors are and how are you going to achieve this price advantage?
As we said, the competitors is right now the market is very, very young. So actually, there's not really much production in most countries right now. For example, in Mexico, last week the first biochar plant was inaugurated. So it's a very young thing that is happening right now. So they are not really developed at the scale as to there's enough biochar to have competition with other people. Now, the reason why we're able to achieve those smaller prices is, first of all, because we can leverage in the developing countries, you have lower cost and also more availability of higher quality feedstocks that are available everywhere compared to Europe, for example. And you can also, if you manage to sell the carbon credits to EU companies that are willing to pay probably up to 200 euros per ton for each credit, then you can leverage the scheme. So you have to actually put the whole mechanism in place so you can produce the biochar cheaply in somewhere that it can work with the right conditions that you need to find, where we intend to leverage the technology to help us find these places in the scale part, and then put all this system together to allow us to produce it. And since right now there's not that many people doing it, it also doesn't compete with them.
Yeah, and so maybe just to add to that with concrete numbers. So for example, here we have Terra Fertilis, which right now I think they sell their biochar at like 2,500 euros a ton, which is a lot. That's the highest we've seen. Then companies like Better Soil and the general EU consensus market is like 700 euros to 1,000 euros per ton. And then Net Zero and Husk Ventures, and the price we're aiming for is 150 to 300 euros a ton. So this is like just to give some numbers.
Yeah, and also through our project, we not only plan to really create a local business, but also we will be able to impact the local community around the farmer by providing green energy solutions that can be created during the process of pyrolysis to create biochar.
Okay. Compliments. I think you're the first team today presenting a global solution in instead of a local solution. But that also comes with challenges, because biochar is a fertilizer, and with all fertilizers, it can have, or it can be used as a fertilizer, and all fertilizers have like short-term benefits, but you should use it wisely, because otherwise it can degrade like the soil. It's like giving medicine to somebody without instructions. So I wonder, these countries where you want to use it, they lack regulations in agriculture and land use. How are you going to overcome this and make sure that eventually the use of biochar isn't damaging the soil more than short-term benefits?
Actually, I want to just say something. Biochar is actually it's not a fertilizer, actually. It's an amendment. And so it's something that you use once, and for 10 years it stays in the soil. You can also, which also means that it has its drawbacks at the same time, because you cannot use it the same as fertilizers every year to feed your things. This means that the first year that you use it, you need to put biochar together with other organic fertilizers, or still use a little bit of fertilizer in order to feed the plants. But what biochar actually does is that it helps repair the soil, and it has a very porous structure that allows like a better microorganism environment to grow in it. So what it actually does is that it gives more structure and natural compound to the ground.
And that's it. I'm sorry, the time is gone. This was BioCharge. Thank you.